All right, so let's continue with epithelial tissue. So again, if you know what you're looking at as far as number of layers, you're good to go with first name. And then if you can tell me the cell shape, then you're good with the second name. So the simple epithelium. Simple automatically means one layer, right? Excuse me. So I've got one layer of squish cells, one layer of cuboidal cells, and one layer of columnar cells. So I've got simple squamous epithelium, I've got simple cuboidal epithelium, I've got simple columnar epithelium. Functionally, when we're talking about simple squamous, we're talking about diffusion, we're talking about filtration, some secretion, not much, some protection, not much. But again, if it were me and I were thinking about this common sense wise, I would think of simple squamous being in the lungs. Because in the lungs, I've got to exchange oxygen and carbon dioxide, and it has to happen through diffusion. Okay? So I want you to be able to tell me at least or recognize the functions, and I want you to at least recognize one location for each of these. So, simple cuboidal epithelium. Structurally, we've got one layer of cube-shaped cells. Functions, secretion and absorption, specifically in the kidneys, okay, in the cells of glands. We talked about the sweat glands and the oil glands. Well, these are simple cuboidal epithelium. So I always think of the glands when I think of a location for this, okay? Now you can look here, and if anything else makes more sense to you, that's perfectly fine. There's nothing wrong with that. It's just I'm telling you what my brain does, okay? So, simple columnar epithelium. Functionally, we're talking about movement of particles out of bronchioles. We're talking about the uterine tube, moving oocytes. We're talking about the intestines, the stomach. In the intestines, we're talking about absorption, okay? So, absorbing nutrients. I told you guys that when I think of simple columnar, I think of the intestines, and that's one of the reasons why. So when I think of location, whoops, that's horrible. I think of intestines, okay? When it comes to stratified, again, you've got many layers of cells here, right? And these all look squished. These look like cubes. These look like columns. They're taller than they are wide. So, I know that this is stratified, more than one layer, and they're squished. Stratified squamous epithelium. I know that these are cuboidal, and it's more than one layer, stratified cuboidal epithelium. I know that these are column-shaped, and there's more than one layer, stratified columnar epithelium. Okay? So, function. No matter which one you pick, we talked about the fact that with stratified, a lot of it is going to be protection. All of them have this as a function: protection, protection, protection. Okay? When it comes to stratified squamous epithelium, hang on a second. When it comes to stratified squamous epithelium, you can have keratinized, which is basically hard, or you can have non-keratinized. The two places I think of stratified squamous epithelium, one of them is always going to be your skin. That's going to be keratinized stratified squamous epithelium. Your skin is dry. Non-keratinized, the best example is the lining of your cheek. And again, both of these things are protective. Your skin is protective to the outside of your body. Your cheek lining is protective to your cheek, so that I can eat things like Funyuns and potato chips and stuff like that without me basically rubbing the side of my cheek raw. I have all of these extra layers of cells that if they need to come off, they can, and they protect the underlying cells. Now, stratified cuboidal epithelium. You find them in sweat gland ducts, the ovarian follicular cells, and the salivary gland ducts. So salivary glands produce saliva. That's the secretion function. Sweat glands. I know you're probably going, okay, but sweat is secretion. While that's true, it also protects us from overheating. Okay? Now, stratified columnar epithelium, mammary glands. These are the guys that make milk. So, as far as a function for that, it would be secretion. But in the male urethra, it's protection. Same with the larynx. Okay? Larynx is your voice box. That's what that is. Now, these are the 80% that I said, if you know this, you're 80% of the way there. Let's talk about the two exceptions. Pseudostratified columnar, or epithelium, and transitional epithelium. So, pseudostratified columnar. Remember what I said about it will be ciliated. So if you look up here, see these little hairs up here? Those are the cilia. See little hairs? Cilia. So, function. It synthesizes and secretes mucus. I don't think that's a big 411 if we're talking about anything lining our respiratory tract, our pharynx, our trachea, our bronchi. Okay? So they make mucus and the cilia help protect us as well. Basically, it helps to pull things out of our respiratory tract. We talked about the crowd surfing. Now, transitional epithelium. This and this are the same thing. I know. With transitional epithelium, the reason that they call it transitional is because it changes its shape. The most common place we talk about it being is in the urinary bladder. So what does your bladder do all day long? It fills and it empties, and it fills and it empties, and it fills and it empties, right? When your bladder fills up, it stretches out. Remember we talked about that floppy balloon? Right? So it fills up. When you go to the restroom and it empties, you get all of these cells kind of sliding back on top of each other. So it accommodates fluid fluctuation in volume. That's its job. And again, if you think about the bladder, that makes perfect sense because it fills up with urine, we go to the bathroom and it empties. The thing with transitional epithelium, if somebody were to just give you a slide and no frame of reference, you would probably look at this and either say, okay, those are cuboidal cells, and there are a lot of them. Or you would look at this and go, okay, those are squish cells, and there are a lot of them. If somebody's going to use this as an example of something that you have to identify or something that you have to explain, they have to show you both pictures and they have to tell you, okay, these two pictures are the same thing, so that you realize that there is a change in shape in this tissue. Okay? And what I'm saying is, if I put this on your exam, I'm going to put both and tell you that they're the same. I won't tell you what it is, but you'll know that there's that transition from looking here to looking like this here, so it has to be transitional epithelium. Switching gears, let's talk connective tissue. Okay, connective tissue is a part of every organ in the human body. And what that ultimately means is it's abundant. You're going to have it everywhere. And if you think about the name, it makes sense. Connective tissue connects things together. None of your organs turn into goo. I can cut off your finger and it will stay the shape of a finger, right? It doesn't automatically turn into slime or anything. So connective tissue is everywhere. It is unique from the other tissues, which is why we put it in this category, in the fact that you've got cells, but there is a lot of matrix. There's a lot of that extracellular matrix. So unlike our epithelial tissue where you had cells packed on cells and not a lot of stuff in between, this has cells, but they're kind of spread out, okay? Connective tissue is very diverse, though, in both structure and in function. So when I first started teaching A&P, I kind of called connective tissue the junk drawer because the diversity of tissue that you see in connective tissue is huge, going from, let's say, the liquid connective tissue of the blood to the hardest concrete connective tissue like bone. I mean, you can't get any more different than that. But there's a whole bunch of these. But these are the things they all have in common, regardless. So the functions of connective tissue, the functions of connective tissue, the functions of connective tissue. 1. Enclosing and separating other tissues. Connective tissues form capsules around organs, and they form these capsuled layers that separate things from each other. So the best way that I can think to describe it is something that you may have seen. When you hook up your gaming system and you hook up your TV and you hook up the Blu-ray and you hook up the, let's say, the satellite box to your television, right? And you've got that whole setup going. Every wire has its own rubber coating. Yeah, you can put them into one bundle with zip ties or whatever, but it's not like they all fuse into one big wire. Our connective tissue does that with our nerves, with our arteries, with our veins. It creates this kind of separation capsule so that an artery stays an artery, a vein stays a vein, a nerve stays a nerve. Now, I can bundle them together, don't get me wrong, but they're still their own individual pieces. This shouldn't be really shocking. It connects things to each other. Connective tissue connects things. No. Yes. So, tendons. Tendons hold muscles to bone. Ligaments hold bone to other bone. That's why you don't dislocate your shoulder if you raise your hand. Muscle is not a connective tissue, so I can't use it specifically to connect to something else. I have to have a go-between. Tendons give me that go-between, and it is a connective tissue. So on one end, it's connecting to the muscle. On the other end, it's connecting to the bone. 3, supporting and moving parts of the body. Okay. Bone is a type of connective tissue, and it provides our soft tissues with a framework to sit in and on. If you think about our skeleton looking like a cat's skeleton, we would look a whole heck of a lot different, right? Our skeleton looking like a turkey skeleton, we would look a whole heck of a lot different. When we talk about supporting, literally, our skeleton supports our weight and gives us our shape. Now, as far as movement goes, our skeleton is one big pulley system. Our elbow at the joint, our wrist at the joint, these are the ways that our bones come together to give us pivot points so that the muscle that actually does move and contract can pull on it and help our body to move. Storing compounds. Adipose tissue, also known as fat tissue, stores fat. Okay? And we've got it. We've got fat tissue, and that's okay. We're supposed to. We're supposed to, because when we were designed through evolution, when our, ancestors, the ones that were the most successful, were the ones that were able to store fat tissues in good times, or adipose tissue in good times, so that when we hit, lean times, we had extra in our body. Now, bone is actually a way for us to store minerals, specifically calcium and phosphate. It is easy for something that lives in the ocean to get access to calcium and phosphate just by swimming through the water. We came out of the water, so we had to come up with a way of storing those things in our body so that we could carry it with us when we got out of the water. Our bones allow us to do that. Calcium is seriously important. I'm sure everybody knows, drink milk for strong bones. And while that is true, other things use calcium. Your muscles use calcium. Your nerves use calcium. So your brain function depends on calcium. Your ability to breathe depends on calcium. The ability of your heart to beat depends on calcium. So having a way to store it is really important. Okay. 5, cushioning and insulating. This goes back to adipose tissue. Cushioning. The more adipose we have, the squishier we are, right? We actually have 2 organs that sit slightly below our rib cage, our kidneys. Here is this bony cage that's supposed to basically protect our organs from impact, right? And yet we've got 2 organs that sit slightly below. Whoops, flaw design, right? Or design flaw, I should say. Flaw in the design, or design flaw. There we go. Either way, the fact that you've got that design flaw means that we kind of had to come up with an alternative. So what did we do? We put fat around the kidneys. And it's supposed to be there. It doesn't mean you're fat. It's supposed to be there because if I accidentally bump into something with my back, I don't want to rupture my kidney. I don't want to rupture my kidney and end up with, a bleeding kidney. Instead, if I bump into something with my back, it's like having a pillow on top of my kidney. The pillow takes the impact, not the kidney. So it's cushion. This is one of the reasons why rabbit punches or kidney punches are illegal in boxing, because people were doing that and rupturing kidneys because of the force of the blow, and people were bleeding out in the ring within a minute. So yeah, it's illegal. Insulating. Insulation in your house makes it so that if it's cold inside, it stays cold, or if it's warm inside, it stays warm, right? Everybody knows the fat girl, that would be me, who has a lot of insulation, and I'm always hot. And everybody knows that skinny girl who's always wanting a sweater. It's 135 degrees outside. No, I need my sweatshirt. Oh, sure, whatever. But literally a big portion of that, a big reason why my body can hold on to heat, or hold on to heat, is because I've got enough adipose that it holds on to it like a thermal cup would, like a styrofoam cup keeps your coffee hot, a Yeti, right? So it is insulating in that way. Transporting. Okay, so one of the examples that I gave you for a connective tissue is the blood, right? Blood is like the ultimate transport system in your body. While your arteries and veins are kind of the highway system, the blood is the cars. So it transports oxygen from your lung to the tissues in your body. It transports carbon dioxide from the tissues in your body to the lungs. It transports nutrients from your intestine to the cells of your body. It transports waste products from the cells in your body to your kidneys so that it can be taken out in the urine. It is ultimately a huge transport system. Now, finally, protecting. 1, your immune system. Your immune system is derived from your white blood cells. Sorry. brain fart. It's derived from your white blood cells. So that immune system has to be able to protect your body, right? Well, that's protection. White blood cells that go out and kill invaders and do all of that, that's a protective function. Um, the bones. The bones are created to protect your soft insides. If I come up to somebody and I punch him in the side of the head, am I going to hit their brain? Most likely not. I mean, I'm strong and all, don't get me wrong, but I mean, I'm not actually going to do any damage. I'm going to hit the skull. I'm not going to hit the brain. Same with if I come up behind somebody and I hit them in the back. Most likely, I'm going to hit their rib cage or their vertebra. I'm not going to actually hit their lung or their heart. So it's a protective cage. It performs a protective function. So there are 7 functions to the connective tissue.